first of all, when you look at the Agro Industry pilot, the starting point was What Should Grow, which was an existing platform at the beginning of eShape. So that's what I will do first. It's a bit start from there in my explanations. So What Should Grow, it's a platform really focused or targeted towards farmers in Belgium. And mainly potato farmers. That's why it was developed. That's how it was conceived. And to this day, most of the uptake or the use has been by potato growers and the potato processing industry. So I just want to show you a bit the platform as it exists today, and then start from there to show what we want to do in eShape and what we have actually achieved so far through the different work packages in eShape. So if you log in, I use a demo account here because I'm not allowed to show any actual fields because farmers actually put a lot of personal information in there. So I cannot show their fields. I can only show some of the demo fields that we delineate ourselves and where no personal information is available. So that makes also that the list is quite long. But so when you log into the platform, you get an overview of all your fields. And basically what we try to do in What Should Grow is initially it started as What Should Grow is a platform to bring EO data to the farmers to make sure that they can do better decision making, that we can inform them, that we can add some services on top of EO data. But now over the course of the different years and based on the needs of the growers, it really has more and more been changing into a data exchange platform. And so that's a bit what I want to show. So for example, you get your overview of all your fields. You can also look at some global maps of the area, but I won't go into too much detail there. But for example, if we take one field, if you click on the field, the farmer immediately gets a general overview of its entire field. For example, the current state, where are we in terms of the greenness, so the development. And also, for example, data that should be provided by the farmer, like planting date, harvest date, actual yield, and so on. And he gets an overview of the current state as well. So that's a general dashboard from which you can then start to look into more detail. I think one of the most interesting components that we have, for example, is EO data really has focused on trying to provide services in terms of precision farming. But there's also much more to it than that. For example, here we just show, for example, the history of the field for the past 5 years now already. So everything starting from 2016, just showing which crop was growing the past 5 years and how well did it do. So what was the general variability within the field? So the farmer knows how well it was performing, were there any issues in the dry years and the wet years, so that he can take that into account when organizing his new growing season. Also, there's a range of warnings that are included. For example, when there's actual leaf development or crop development starting, so when it's really the emergence and the fast crop development happening. And like in this case, if there's very strong variability in the field, there's also some issues attached to that. And there's a whole range of issues, but since it's only the start of the growing seasons, there's not many active just yet. And so there's a wide range of applications already available. For example, this one is also a nice one that we have as of this year, is where we connect, in case of irrigation, we try to link water availability and water demand so that the farmer can see, okay, I would like to irrigate, but I'm not allowed to take water from the river anymore. So are there any companies offering residual water from their processes? And then he can contact them and see if he can buy some water from them to irrigate. And so there's a whole range of applications, and that's also what I mean with it's really turning into a data exchange platform, just more than just a pure EO service dashboard. Also, for example, here with the My Connections, we try to be as open as possible. All the data is open. Farmers can connect to any other existing platform. For example, here, these are just a few ones that are active in a demo account, but there's more. For example, they can connect to the soil service of Belgium, Agro, which is also a service provider, for example, to order soil samples, to order irrigation advice. They can get drone flights if they want. Also, for example, they can connect to the data from their machines if it's integrated into their machines. So it means it's really trying to integrate all the different data sources. So that's a bit the starting point. I think, yeah, an example of that integrated, let me see, soil data. I can show that. So that's for an example where we have that integrated. For example, if they have a soil scan, they can also integrate it into Watch It Grow, and then can actually visualize it as well together with their satellite data to see if the variation in their field is, for example, related to the variation to the soil component, or is there something else playing, so they can visualize both. I noticed that this feature is quite slow. I should have loaded it before, so I will skip it for now. But that's a bit the general idea and the starting point. So this is where we started in eShape. This is what we have, but of course, this is very specific in the sense that it has been made for Belgium. In that sense, if you look at data infrastructure, it's built on top of Terrascope, which is the Belgian collaborative ground segment. So we have the Copernicus data for Belgium all available, so we can build services on top. So for Belgium, we were covered with the Terrascope platform. But of course, there's also demand for other countries. There's demand also for Africa, for China. So what do we do if we want to expand our geographical extent? Then we cannot keep just ingesting all data ourselves. We need to find more cloud-based solutions as well. So this was also one of the questions we brought into eShape. How can we organize ourselves to be more flexible in terms of geographical offering? What else did we want to do? Well, this is Potato for Belgium, but of course, there's many other actors that can be involved and that would like to use this type of platform. So there's this whole co-design. When somebody is interested in using this platform, does it actually serve its needs? What do we need to change? Does it require new services to be incorporated, or is he happy with just what's already available or not? So Bird Package 2 has really been a good help. I will go a bit more detail later on. But also really new markets. For example, this is really towards farmers, which makes it very specific. For example, it's very detailed at the parcel level, but it's hard to extract some general information over a region. We cannot show you where in a region, for example, drought is hitting really hard, like we saw in some of the other examples before. That's not what it was made for, so that's not something it can really do. So when trying to find new markets, finding new markets also means new demands. So that's a bit what we want to see in eShape, like what would it require to expand to other markets as well. And so that's how I bring it to the first results. So I go back to my presentation. So one of the new users that wasn't identified through the co-design. So we started off with a list of potential interested users, but in the end only CSC remained. And what do they do is actually an interesting application. They're not farmers, but they have seed multiplication fields. That means that they grow new varieties for seed producers. So if they have a new variety, they need to make sure that there's enough seed to sell. So they just grow the crop of interest and harvest the seeds themselves and not the crop. And their main question is, when do I need to harvest? Because it's really important for the seed quality that they harvest at exactly the right time. So they would like to have more information on when exactly do I need to harvest. A big issue that they have is they only have a limited number of fields and they need to be far away from each other because they cannot have cross-contamination between different varieties. So they need to be far away, but that means if they want to know when to harvest, they have to travel a lot. They drive thousands of kilometers a year just visiting all the fields to see if it's already mature enough before they can harvest. So they came to us, can you do something about that for us? So that's where I then go back to the platform. So Belgium, I go to Italy, to the fields of CSA. Again, these are a bit mock-up fields because we're not allowed to show their actual fields. But in the end, what they wanted to know is, when do I need to harvest? When are the seeds mature enough? So basically what you see is the list of their fields, where they are located. So that's everything they ingested themselves. And what we do then is, for them, estimate the optimal time of harvest. And that's basically what you see here. So that's the new service that they requested, and it's integrated into Watch It Grow. It says when you have the I from information behind it, it means that it's an advised date, it's an estimated date. So this one should be harvested tomorrow, this one should be harvested next week, and the one in between is actually not mature enough to already make a good prediction. So we only predict maximum 10 days before. So that means they should not be harvested the coming 10 days. So this is the new service that was integrated, and they're really happy with it. They started looking at it. It took some iterations to do the developments, but in the end, now they are looking to see to what extent it's really useful and what the advantage is for their daily work. So that's a bit the how should I say, the culmination of all the work we did in terms of EO developments, code development, seeing what their needs are, how they need it, and so on. It's basically just in one table, one date with a little I behind it. That's the culmination. So there's basically also, for the user, no real EO data knowledge required. They don't need to understand satellite data. They don't need to interpret any images themselves. They only need to have a date, and that's what they get. And everything that runs behind it, it's not really visible for them, but they also don't really need it to be visible. But of course, this is a EO-related project, so I still wanted to show you a bit of all the hard work that goes behind it, because in the end, what we show in the platform is just one date, but it's quite a lot of work that went behind it. For example, you need to know how can I actually estimate the ripeness or the maturity of the seeds. So there's a lot of tests of which EO data is actually meaningful. So that's the first step. Okay, so we identified the FA-PAR as a good metric to estimate the optimal harvest date based on historical data. But there was a big issue of clouds, because of course it's a very precise service. So if you miss 1 or 2 overpasses of Sentinel in the crucial moment, it has a very large impact on your service. So initially it turned out that they were a bit disappointed what they could do just because of the clouds. So that's why we brought in our analysis, what we have available internally is a COPSAG service, which basically merges Sentinel-1 and 2 to make sure we have continuous time series of FA-PAR. So that means we have a daily observation in the end. It's a bit artificial, but we can actually, especially, for example, if you see the example in the crop development and also in the senescence part, there's very few observations. So there we bring in Sentinel-1 to fill the gaps. And it's something that really works really well. And that brought the service, or at least potential of the service, was approved by CSA, that they said, okay, based on the CropSci data, it is feasible within the requirements to have this service. But of course, CropSci, it was good to do on historical data if we know the entire growing season, but if we need to do predictions, well, there's not really big use because Sentinel-1 still cannot do any predictions, unfortunately. So that's why we brought in Meteo data as well. And basically in the same kind of machine learning workflow, instead of filling gaps with Sentinel-1, we also added Meteo data, so rain, temperature, information, irradiation, to fill in the gaps. That additional information worked really well. And then you can also use your Meteo predictions, so your 10-day estimations, to also do FA-PAR predictions. And what you see here in this graph is actually the red dots are predictions, and the blue line is, the blue line are the predictions that we made, and the red dots are the ones that were filled in afterwards once we had the observations. So based on this, we were able to, and this is a bit the results, to, if you look at, we need to be 2 days precise, we were able to estimate, if you sum them up, it's about 86% of all the fields, we were able to estimate the right harvest dates within a margin of 2 days. So that was it for the presentation. I think I'll have a bit more time. So this is a bit the co-design, and I think just to conclude what we're doing now, and that's on the agenda, is really to see the new markets, because what we have now is one user with the very specific needs, but also look at the new markets, and that's why we also look at, for example, the agro insurance industry. They've discovered what should grow, so we didn't actively contacted them, but they contacted us and they said, well, you have now all this contact with the farmers, you know what's happening on the field, can we use what should grow as the interaction tool with the farmers? Because one of the nice things, the farmers can directly ingest data. They can also, for example, if they go to your field, here the soil scan is now ready, but let me just show you the greenness on top of it. They can, for example, delineate damages. That they say, oh, something happened in my field, I will just delineate it, and it will send it to the insurance companies as well, and then they can take it into account when organizing, for example, their field visits and so on. So that's some of the ongoing work as well this year to make sure how we can facilitate such interactions with different users in the agricultural value chain.